Equality. So, right here.
Oh, Lord.
Oh, man.
Answer
Answer.
Answer for real.
What if it's mom column?
So, I believe yesterday, really quickly guys, right here. Yesterday, we looked at the Tesla and the Toyota Camry, and then for the Tesla, we wrote that the Tesla cost equals 37,000. Ooh, that was the second part. Does anyone remember what the monthly cost was? Was it 319? 319. That was what it was. Yeah. 0.7 times however many months. Remember that was a monthly cost.
12.
Plus, now that's only for 12 months, right? But remember, this is for any number of months,
Oh, right.
right?
Oh,
And how many times were you charged with 39,770? Once, right? Now for the Toyota Camry, right? The Camry cost, I think it was like 340 something?
It was like
352? 354. Alright, I'll look it up again later, okay? Now, and then,
It was 27910. I mean 29887.
I'll look in a second. But regardless, what I want to remind you and I want to point out is, what did we do to figure out when it would become less costly to have a Tesla?
Oh, look at the graph.
We graphed them, didn't we?
Yeah.
Yeah,
And when we graphed them, we looked for a what?
Intersection.
Please. Point of intersection, right? But was it super easy to find that point of intersection?
No.
Remember, we had to like move that graph around a lot. We had to change the window to be able to see it more clearly. And so it was a bit of a pain in the butt. Come on, can you grab that card for me, please? But it was a bit of a pain in the butt. So did we get to the part of doing this algebraically?
Yeah.
I
Wait, I'm pretty sure we did it. You said we were going to do it today.
Okay, that's what I thought. So here's what I'm going to leave off. Are you looking at what the cost was?
Yeah, it was for the Tesla. It was 37,990 for the winders up.
It's literally right there.
For the camera, it was 354.8
354.8. Okay.
plus 29870. Yep.
Yep. Okay.
Good job, Mr.
There we go. Thank you for looking that up. All right. So the Tesla and the Camry costs are right there, and we found it graphically. We found that point of intersection. I'm going to pull that back up a little bit later. But what I want us to be able to do is, I also want us to be able to find this algebraically. Anyone know what we could do here to find out when those costs would be the same?
Yes.
What?
We can table it.
We could make a table, but let's remember this. When we solved this out yesterday, didn't it like take 200 something months for them to have the same cost according to that graph? So do you, you're right, but it was 200 something months or almost 20 years. So do you want to go 200 something months? No, same, I'm out, right? Like I'm not doing that. My question is, how can we do it algebraically? But what am I going to do with those equations? So remember, the graphing is graphical, right? Okay, but so I'm just going to kind of do a generic sketch, okay? So hold on. We looked at that point of intersection. What do we know about the cost at that point of intersection? Oh, the costs are what? The same. So what can I do with this cost and this cost? Mathematically, what do we mean by they're the same? They are, yes, they're not equivalent this time. So equivalent, let's remember this, I should have said this. Remember, equivalent means they look different, but they tell the exact same story, right? These are only the same at this one point. So they're not equivalent, but they are equal. Okay? So the Tesla cost is equal to the Camry cost. So I want you to talk within your group. I want you to think about these equations, think about this equation, just for a minute or so. Come up with a strategy of what we could do algebraically from this point. Okay, so we're just trying to develop a strategy. I'll let you work on it in a second. What's up, Tasha? Wait, two-step equation? So what's the equation? So think about the, did y'all come up with a strategy yet? You just started
What you
discussing
think
it?
I was gonna do with Carl?
Hey,
I had to give him a refresher because he didn't remember.
I got you.
Yeah.
So,
Yeah.
I need us engaging this. Cameron, what'd y'all talk about?
Oh,
Yeah, I
what
see
you
your
say?
hand, I'm choosing to talk, calling other people.
What you say?
Sometimes you don't always get what you want. Cameron, what you notice?
We said.
Whoa, I know y'all said, but I wanna know what Cameron got out of what y'all said.
He ain't really getting nothing out of it, you know, he was out of it. But look, I'm finna
Oh,
tell you
wait,
what
back up, but
Oh, Lord.
Cameron, I need you to know these things.
No, Cameron.
So I need y'all talking about this. I need you collaborating. Think, communicate, collaborate, right? Okay? J Mike? Okay, so first off, I want y'all to hear me on this. You don't ever have to say, I'm not 100% sure about this. I just need you to engage and to try.
Yes,
It's cool. We're learning. You know what you're going to do when you learn?
learn.
Make
You're gonna make mistakes, you're gonna mess up. So like, stop being scared of messing up, just engage in the process and you will learn. Alright? So J Mike said something here about creating a two-step equation. It may be a two-step equation, but let's just focus on an equation. Vikari.
I'm just guessing maybe about 37,000, 29,000.
Okay, but I'm not gonna say yes or no on that yet. I'm asking you to build on what J Mike just said. J Mike said something about writing an equation.
The two-step, we're gonna probably be able to get rid of that eight.
Maybe. What? Mel, Chelsea, Maddie, can y'all build on this at all? Did y'all talk about anything? Okay, you just didn't quite get there? Okay, so I'm gonna give you one more minute. I want y'all thinking about what J Mike said. How can we make an equation?
Oh, two-step equation.
Pause. I'm not quite done. How can we make an equation knowing that the Tesla cost has to equal the Camry cost? You have equations up there. Come up with a strategy. Go.
All she said was restating. She said, I think it means that we need to make an equation.
True. Okay. Chelsea, what'd y'all talk about then?
She had pointed out that on the graph, the cost and the months meet at a point, so she was like, maybe we should just multiply the months with the cost.
Okay.
That's what I did.
Now, remember, we want to be building on what J Mike said. Guys, if you're talking about things that aren't building on what he said, that's not helpful right now. You can do something like that. Hold up, back up. Guys, really quickly. Should we be talking about a vertex with this type of problem? Why not?
Not back.
Guys, it's the vertex form of a quadratic. It's not what? This is not quadratic. This is what? It's linear.
Yeah, I don't see no parameters.
Okay? Alright.
Okay.
Chris, start me out. What are you looking at? Because I see you writing some stuff down. What did you write down? But literally, though, what is that equation that you wrote down? Come on, use some more words. I see you have more written down there. You said the Tesla cost. What did you write down for that Tesla cost? So you literally just wrote down the equation for the Tesla cost?
Yes.
Oh, and then it equals what? The Camry cost. And what's the Camry cost?
3, 4, 8.
Hey guys, the costs are the same. Yeah. So you set your equations equal to each other. That's it. Well, remember, hey guys, remember what did we say? At this point, those costs are what?
I ain't know what
Hey guys, the costs are what? The same. We literally said the Tesla cost is equal to the what? Camry cost. And don't we have an equation for that Tesla cost?
Yup.
Pretty sure.
So if this, guys, I need y'all to notice this. If this is equal to the Tesla cost, what's a mathematical term for what I can do next? Why did this Tesla cost become this? It's an S word.
the same?
Subtract.
The solution.
The subject?
So,
Subject.
say it again.
Subject is in.
Say it louder.
Substitute.
Guys, we're substituting. Come on. If those two things are equal to each other, then I can substitute one in, right? Now, at this point, we have our equation. What I need for you to do is I need you to go to your vertical surfaces and work for a couple minutes on solving this equation. Leave that there. I need to talk through a couple of things that I'm seeing that I need us to be careful about. I want y'all to look around the room. What is the most common answer that we have for what x equals? 231.34. Really quickly, Kamaya, can you pull the screen down over there?
I thought that was 3.
That's a good, yeah, it's good.
That's a 3.9, though.
I want y'all to look at that graph right there. Why am I pointing out that graph?
Because the number right there. 1, 4, 5.
3, 4.
What is the x?
4, 1, 5, 9.
The X is.
The x is 231.34, right? We already did solve this problem graphically. We're now trying to do it algebraically. So we should already know it took how many months for them to cost the same amount? 231 months, right? So I want us to recognize that. I want us to think about that. So we got, a lot of us have that same answer around the room, but I want to address some important concepts that we are missing on solving. Now, I didn't create a fair model for this, so you're going to need to take note, pay attention, and take notes on your own to help improve some of our understandings. And hear me very clearly on this. One, J. Mike, Taj, Amber, it's hard to learn when you're not actually paying it, like looking at the board. Two, I need you to not just write down the steps, I need you to make sure you understand and explain why to yourself. Because there's some really important ideas that are going on here. And so I'm going to kind of build it off of, I'm going to rewrite it just so it's a little bit easier to see. 319.7x plus 37,990 equals 354.8x plus 29,870. So first off, if I am going to solve an equation, what do I need to use? I mean, there's already an equal sign that makes an equation, but like, I saw a lot of us subtracting. Why were you subtracting? Because what? We weren't using substitution. We weren't substituting in, well, we got
I mean,
this.
it's just like the
From
back way.
substitution.
Remember, like on the positive.
You know, there's a lot of technology over there that you could easily break by playing around a little too much, right? Let's fix that. Dwan, you're supposed to be in the center of the room. Center of the room. Center of the room. Just space right here. Thank you, sir. All right, guys, come on.
I know what.
Demaya, I need you closer. Maddie, I need you closer. Kalia, I need you closer. Guys, why were some of us, and I'm just going to choose this one to subtract. Why were so many of us subtracting here?
It's just like back and forth in a way. Like, think about like on X.
So there's an I word here. What did Dwan say?
Inverse.
Inverse. And I know some people are saying stuff over here. I just saw Jamie saying this. What were you saying, Jamie? It's making a what?
Zero.
A zero.
So he asked me.
Right? Please note, like, I'm not trying to make this a mystery. When we are solving, we are going to use inverses. Those inverses create zeros sometimes, right? But remember, I just changed the right-hand side of the equation. I need you to pay attention to this. Is 7 equal to 3 plus 4? That's a true statement, isn't it?
Yeah.
7 equals 3 plus 4?
Yep.
But what if I subtract 2? Is that now a true statement?
No.
How could I make this a true statement? What could I do to that 7 to make it a true statement? Minus 2. So as long as whatever I do to the right-hand side, I also do to the left-hand side, does that stay true? What's that called when whatever I do to one side of the equation, I do to the other? Properties of
Equality.
Okay, when you use an inverse, you have to use it with a property of equality. And there's lots of properties of equality, but they're really, I'm not even gonna stress the names, because if I say the additive property of equality, that just means what I add to one side, I add to the other. So, the subtraction property of equality, whatever I subtract from one side, I subtract from the other side. That's all it is, but it's properties of equality. If I'm solving an equation, I'm going to use inverses with properties of equality. Now, that's only the starting point. I need you to hear me on that. That's a foundational piece. That's not always all you do, but that's a foundational piece that we've got to understand that this is the beginning of solving equations right here. So what I did to the right-hand side, gotta do to the other side. Now, I'm gonna show something in a second. And so notice I just put a little bar there to indicate equals, right? Like I'm finding what this is equal to. I saw some people doing this, and I need you to be careful. I saw some people doing this as well. And mathematically, this is correct. As long as I do that to the other side as well, it works. However, what did I just make here as well? A 0, right? I made this a 0, and that's not what I want to make a 0. I already made this piece a 0. This can work, but what's going to be on the right-hand side of this equation?
0 as well.
A 0. Like that's it, right? Like if I do that also on the right-hand side, I'm left with a 0, and I'm left with this. They're not equal to each other. Is it negative 35.1? Okay. Notice they're not equal to each other. Plus 8,120.
Yep.
Okay. Those are not equal to each other. It's equal to 0. That's not necessarily what I want to do. What should I have subtracted second to make this work and work nicely? If I made my constant a 0 on the right-hand side, what do I want to make 0? The what on the other side? What's that?
Who's that?
Y'all, it's Mr. Kim. Chill. He's a college student. He's taking care of himself. Y'all learned something. All right. So, I will say this. Notice how I call this a constant? One thing you could call this is a linear term. If you want to call it to that. You could also just call it the variable expression. The reason I call it a linear term is because it's x to the first. If it was x squared, do you know what term I would call that?
Wait, what's cube repeat again?
Y'all, isn't x squared quadratic?
Yeah, man.
We gotta be careful, right? Remember, exponential is like 2 to the x. So if it was x squared, I would call it which term? Quadratic. Any guesses what I would call x cubed? Cubic term, right? Like that's it. I just want y'all to understand, like that's what I can call it. So I'm gonna make this linear term on the left-hand side equal to what? Okay. Now again, you could make this 0, but I don't recommend it. I subtract this, and notice one thing that I'm doing, does anyone see what I'm doing? One thing I'm doing that a lot of us are not doing? Look at it above. What am I? I'm putting that 0, because what's the goal? What's the point of this? I'm trying to make a 0. That's the idea, those inverses. I'm trying to make a 0, so I'm showing where I'm making a 0. And now this equation is significantly easier to work with. So this is 8,120 equals 35.1x.
See, I had to.
What do I do to solve that equation?
You put the 8, you divide 35.1 by 8,120.
So I take 35.1 and I divide this by 8,120. Anybody want to add on to or push back on that?
Okay, that's a, that one, you did negative 8.
Oh, so you divided by 35.1.
Yeah, it was negative 2 though. Ms. Kim was showing us.
But, hold on. Sorry, I got people talking so they can't be learning. What is happening in this equation so that I can solve it? I am going to divide, but what's happening that's telling me to divide? I'm sure we had a math teacher in the past who just called it two-step all the time and we don't fully understand it, but like, no, I'm just asking, what's happening here that I can undo? There's multiplication, where?
35.18.
35.1 times x.
And 35.1x.
I need it to become a what? I know, so what do I need to do to 35.1 to make it a 1? I can use that reciprocal or I can just divide. Guys, hey, what is anything divided by itself?
1.
Oh! Is it a lot?
I ain't told you. I told you.
Guys, listen, if I'm adding and subtracting, does anyone know what I'm trying to create?
A 0.
A 0. If I'm multiplying and dividing, you know what I'm trying to create? A 1. Because how many x's do I now have? 1x. And whatever I do to one side of the equation, gotta do to the other side. What's that called?
Inverse.
We gotta learn our vocabulary. That's not the inverse. Properties of equality. 231.3 months later, the cost of those two vehicles are the same. Remember, the inverses is creating the zeros and the ones. What I do to one side of the equation, I do to the other is a property of
Equality.
Stuff recorded.
Say again?
Glad you got stuff recorded, 'cause I can't.
We're about to also get some more practice with this. Does anyone have a specific question before we do another practice problem with this? Picard.
So Miss Kim showed me right there that you see how we got children 31.3.
Yeah.
So you see how at the top right, he told us when you first told us to do like the negative 354.8 on that side, right?
Right.
And then you see how he told
Picard, back up a second. I'll answer your single question in a second. Did you get the same answer?
no, he shows me do it as he got to 31.339.
Wait, 231.34 and 231.339?
Yeah.
You rounded.
It's rounding, bro.
That's the same answer?
No.
Okay, my bad, I didn't know that. Okay, I'm good then. Alright. Alright, we all good then. Everything good.
Alright,
Ready for
hey,
this?
time for our next one.
Stop writing.
I'm ready for this.
Ooh, okay, ooh. So, here's the thing. Remember, we just pointed out that long term, like, it took almost 20 years. Hey, it took almost 20 years for the Tesla to become cheaper, right? But that's not the only consideration for some people when buying a Tesla. Hey, I'm still talking and I need you to hear this. What's the other consideration for buying a Tesla besides just the cost?
It saves the economy.
Saving the economy. I'm not saying everyone else is into that. Some people don't care about that. Some of us like, I want the biggest engine taking up the check, right? So, some people's consideration, listen, some people's consideration is what is better for the environment. So I do want to point this out. Which car is better for the environment to produce?
Electric Tesla.
The gas one.
The gas one, actually. The Tesla to produce is actually really bad for the environment because the batteries,
The lithium batteries.
you cannot recycle the batteries. The batteries are actually really expensive to create, and there's a lot of process involved in mining some metal. Is it the lithium? There's something else. I have to go back and look what it is. But there's a heavy metal that's in it as well that's really bad. So notice, is the Tesla better when you initially buy it?
Wait, no.
So notice that's way more emissions. That's way worse for the environment to start. However, that is just the start. By the way, if that's just the start, does anyone have an inclination what that might also be called when we go to look at our function? Well, that might be the y-intercept? Oh, we might want to hold on to that as our y-intercept, right? I'm not saying it is, I'm not saying it's not, I just want us to remember that's where we're starting. So, in your small groups, go back to this tiny URL, and there was actually another graph about the emissions. And I need you to pull up those emissions. I need you to figure out which one is going to be better for the environment long term. All right, so we got this starting point for the emissions. Let's pull up the website. If you need, because none of you have it, You can see it
Yo, there's
on my laptop.
Appreciate that.
And trying to put expo marker on someone's face. It's really hard to be productive
Put it in there.
as Preston.
Why you got called out twice in 2 days?
Like, guys, listen,
Calm down on me.
listen, excuse me.
Well, you do what you're supposed to do. I
Preston,
am.
listen. Your education matters. I cannot emphasize this enough. Some of us are trying to screw around a little too much. And it's gonna bite you in the butt because I'm gonna expect you to learn because one, you're more than intelligent enough to learn. I don't wanna hear you calling yourself regular students, because you're not. You're intelligent human beings capable of learning. However, some of us are playing around a little too much. We gotta get to learning. We gotta make sense out of these things. A lot of us did a really good job of writing an equation. Now, I need us to be careful and pay attention to something. This 11,000 right here, how many times did that happen? To make a car, that's only happening one time, isn't it? And then every month, there's a higher emissions. The 7,000 for the Camry, how many times was that emissions? Just once. So we're not repeatedly adding that. We are repeatedly adding those extra emissions. Notice around the room, because we're not redoing this tomorrow, we're going to pick up with the next set. What did we have over here? Notice we have the Tesla. Look out, Chelsea. We have the Tesla emissions here. And we have the Camry emissions here. And we want to know when they are what? The same. Oh, come on, even better math. They're equal, right? Because originally, which one is better for the environment? The Camry was better, but eventually the Tesla is better. And so we want to know, when does that switch happen? How many months down the road? And here it is. Whoa. Oh. I think it's supposed to be 34.4. Is that right? I got you. So look, 34 months down the road. Hey guys, would you hold on to a car for 3 years?
Yeah.
So if you care about the environment, in 3 years, which car is better? The Tesla, right? If your priority, I'm still talking. I do. Like, this is ridiculous. You're too old for this. When we come in tomorrow, by the way, I'm going back to 8th and 9th and 10th grade content to make sure we're ready for the next piece. I need us more engaged tomorrow and ready to go, because on Friday at the latest, we're starting quadratics. I'm solving quadratic equations. These are just linear. We got to get going tomorrow. Is that clear? Solve your equations using what? Guys, how do we solve those linear equations? With? Equality.